This is the second related rates problem. You shouldn't be looking at this until you've seen Introduction to Related Rates. Okay, this is a very simple problem about a kind of magic square. It's a square, all the sides are congruent, but its sides are all increasing at the rate of 6 centimeters a second. That's what's given. And we always draw a picture, but in this case, the picture isn't lending a lot of information. It's just prompting us to name the variable. And we have to know at what rate is the area of the square increasing when the area of the square is 16 square centimeters. So the derivative we're given ds dt is 6 centimeters per second. Remember, it's positive because it's increasing. And what derivative do we have to find? dA dt. How fast is the area of the square increasing? And when do we want dA dt? Well, we want it at the particular instance when the area is 16 square centimeters. Now, at this moment, we might not be prompted to figure out what the side is when the area is 16 square centimeters. But as soon as we start finding the derivative, we're going to realize that's what we need. So, here's our equation. Here's the important equation that relates the variable whose derivative we have with the variable whose derivative we have to find. So we take the derivative with respect to time. dA dt is, well, here's chain rule, the function squared. So 2 times the function, 2 times s, times ds dt. And now we have to plug in ds dt is 6 centimeters squared, but we need s, not a. So if we go back to what our when condition is, our when condition is when area is 16, but area is the side squared, so that would mean the side is 4 centimeters. So we plug that in. 2 times 4 times 6 is 48, and centimeters times centimeters per second is centimeters squared per second. And once again, it's important to notice that the units help us. Area should be increasing at a square unit per second. And if we just plug in the numbers with their units, we do in fact get square centimeters per second. And that is how fast the area of our magic square is increasing.